Joinery, which is the basis of all Japanese woodworking, demands sharp tools to get clean and efficient cuts. Kyozo Umeda is a toolmaker from Niigata in western Japan. He has been making knives by hand for 44 years. Mr. Umeda represents a long tradition of handcrafted toolmakers in Japan. Umeda are totally out of step with what we think of as Japan Incorporated. Japanese toolmaking is a pre-industrial craft, one that developed before Japan or the world became so mechanized. It represents the accumulated knowledge, skills, and traditions of generations of craftsmen. One thing that makes Japanese chisels and plane blades so special when compared with Western hand tools is the way they're made. A piece of hard, high-carbon blade steel that will take and hold an edge is laminated to a soft, low-carbon body that acts as a shock absorber. The hard and soft steels are placed together. Boric acid and iron powder are used as a flux to help fuse the steels. The laminating work is done when the steel is at about 1900 degrees Fahrenheit. Then the blade is shaped at about 1600 degrees Fahrenheit. Next, the blade is quenched to harden it. After quenching, the blade will be annealed by reheating to give the steel a more uniform texture and flexibility. This is Chutaro Imai, another tool maker from Niigata, Japan. Mr. Imai has been making chisels by hand for 27 years. He also hand fashions, slicks, timber chisels, gouges, goosenecks, and other custom-made chisels that are highly valued by woodworkers in Japan. Today, this old tradition of making tools by hand is in danger of dying out, as fewer and fewer Japanese young people choose to take up their father's professions. Many Japanese woodworkers, too, have given up on traditional hand tools in favor of the increased use of power machinery, sanders, and routers. The more mechanized you are, the more distance there is between you and your work. What makes traditional Japanese-style woodworking so special is the relationship between the tools you use and the kind of work they allow you to do. These tools are so responsive, so perfectly balanced, that your personal skill is all that separates you from the wood you work on. Japanese tools put the focus back on the magic place that exists between the craftsman and his craft. If the job doesn't come out right, you can't blame it on your tools. What seems most Japanese about all this is simplicity and balance. The simpler and more direct the working function, the easier it is to see what adjustments need to be made. Balance comes from the way the work itself, the materials you use, and the tools you build with all combined in the final product. Seeing how these tools are made and understanding the craftsmanship and tradition they represent can have important consequences for our craft and can inspire us in our own work. Tools of this quality deserve all the respect and care we can give them. Hello, I'm Jay Van Arsdale. This is a chisel that Chutaro Imai was just making. It is a remarkable tool. Let's look at it and see how he put it together. It has a piece of high-carbon steel laminated to low-carbon steel. The high-carbon steel is always the cutting edge. The low-carbon steel is a shock absorber and extends with a tang back into the wooden handle. The wooden handle has a metal ferrule at the top which keeps it from splitting as it's hit with the metal hammer. It's important that this ferrule be down 1/8 of an inch from the top so that it's not hit with the metal hammer or it will rock and cut the top of the chisel off. These chisels are always very balanced and they get extremely sharp. These types of chisels are the mortising chisel and the slick chisel. The slick chisel has no ferrule on the end and is used for only final paring and cleaning up. It's not hit with the hammer. There are different styles of chisels made under the same type of construction. This is the regular mortising chisel. This is a timber framing chisel. As you can see, it has a much heavier construction and longer shank so that it can reach into the depths of the deeper mortises that you encounter when you're doing timber framing joinery. All these chisels come in general sizes from 1.5 millimeter chisel to a 48 millimeter chisel. They all have the same type of laminated construction, and the handles are all the same. Other styles of chisels made are the convex and concave gouges. These are very handy for cutting the inside of curves or circles that might come up in your work. They give you very clean cuts because they have the laminated blades. One other style of chisel still made in Japan is an old style chisel called nomi, or fishtail chisel. As you can see, it comes to very flared light points on the corner. This is handy for using when you're cutting dovetails, although it is somewhat fragile in the corners and shouldn't be used for prizing or for heavier work than it was designed. The paring chisels come in the same sizes as do the mortising chisels. This is the cabinet style chisel. This is a timber framing chisel. As again you can see, the slick chisel has a much longer shank and has a much heavier construction. This longer handle and shank give you more leverage in your work when you're working on bigger pieces to get the cleaner cuts. Again, it has the same laminated blade and will get as sharp as your regular cabinet style chisels. Another style of slick chisels made in Japan is called gooseneck chisel or trowel chisel. It has a laminated blade, but the straight handle has an offset in it so that you can reach the bottom of a mortise that you can't reach with a straight chisel, or a dado that's impractical with the straight chisel. I use machines for milling and for some of the heavier work, but I use my hand tools for all the joinery that I do. This joinery has a wide range of possibilities and applications into our projects, and they're very satisfying to work with. These tools are very good, durable, practical tools and will last a long time with proper care. This care includes keeping them dry and not letting water get to them or they will rust. It's also important to have very safe work habits, and that you can cause injury to yourself if you're not extremely careful. What we will cover here in this next hour or so is the basic use of these tools and their care. We will also explore the basic mortise and tenon joint that you can use in your projects and some of its variations. One good starting point with mortise and tenon is the sawhorses that we have here that I will be working on. Later in this session, we will look at a set that are much lightweight and more elegant that are used for general work in your shop. It's also important to keep in mind the general hand position and body position when using these tools. That's one of their main work functions, is working at a lower center of gravity where you can use more of your body weight. The grip and the holding of the tools is also important to get the most effective use out of your tools. So, before we start using them, let's take a look at the sharpening and polishing. We'll do this with the Japanese water stones. As I was just saying, to keep your Japanese tools sharp, they're maintained on Japanese water stones. There are a great range of water stones as compared to Western oil stones. These stones have a broad range and a broad effect on Japanese steel and Western steel. There are basically three categories available for use today: rough stones, medium stones, and polishing stones. These stones are all lubricated with water and come in natural quarried stones and man-made artificial stones. It's important to remember that all natural stones should be sealed on 5 sides with paint or varnish in order to keep the water from absorbing into cracks and inclusions and having the stone deteriorate over time. The rough stones today are very efficient, made by man-made processes. These stones exist in grits from 800 to 1,000, 1,200, and 1,500 grit. Some of the brand names available today are the Aqua Stone, the Takenoki, the Bester Stone, and King Stone. These rougher stones are used to take out chips in the blade and to shape the blade in its primary state. There are also rougher natural stones available and other stones that have coarser grits, but they're not generally used in daily maintenance. For these water rough stones to be used, they should be soaked for 45-6 minutes until they stop bubbling. They only work once the matrix in the stone itself has been saturated with water. They need to be put into the bucket before they're used. The next stone in the series we use are called medium stones or blue stones. These are only available in natural stones. One type known as Tashima stone comes from under the bay in Nagasaki. The other stone that's available is the mountain blue stone, which comes from a quarry in the mountains near Kyoto. These stones are used to remove the rougher scratches from the rough stone and make your tool and edge much finer and sharp. This will give you a wire edge. There are no artificial middle stones. The stone that's used after the medium stone to bring up the polish and the luster and the metal are called finishing or polishing stones. These stones are available in man-made artificial stones and natural stones. The artificial stones are available in grits from 3,000 to 6,000 to 8,000. Natural stones aren't rated as a grit, but they're rated in a series between 2 to 3 up to 8 or 9, with 7, 8, and 9 being the highest quality. These natural stones are quarried limestone that comes from the mountains near Kyoto. There are many grades and many varieties, and the general rule is that quality will follow the price. When you compare the results of polishing a chisel or steel on a natural stone and a man-made stone, it's very easy to see what the difference would be. This chisel was polished on an artificial stone and has a very chrome luster to its surface. It is sharp, but the surface of the steel lacks what the natural stone gives it. As you can see, the natural stone has given this chisel a very nice luster and has highlighted and accented all the laminations and the forging work that's present in the steel, and it has a very satiny luster. The properties of polishing are balanced between the steel and the stone with another stone called the white nagura. This is a natural stone that's a soft stone and almost chalky in its feeling. It's used to supplement the stone your primary stone that you're working on. It contains mostly a clay compound which balances the cutting action of the stone itself with the qualities that are inherent in the steel from the maker's forging and his annealing. It is important that you experiment with this nagura and the stones that you're using to get the most effective use out of your stones. So, to sum up again, we have the 3 kinds of stone: the rough stones for shaping up your blade and getting the desired shape, taking out the chips. We're using the middle stone, the blue stones, for taking out those scratches and giving us a nice sharp edge. And we're using polishing stones to polish out these other scratches and to make our edges impeccable as we need. So, now that we've discussed this, let's go to the polishing area and see how these work. Here we are at the sharpening area. It's not necessary to have a totally separate place for sharpening, but it is important that you have an area that is clean and well lit to do this. What is needed is an area that you have your water source for soaking your stones and lubricating your sandpaper and your sharpening. You have your sharpening block to work on, and you have a flattening surface of slate or marble, a piece of laminated glass with wet and dry sandpaper on for flattening and truing your stones. For rough stones, I use 120 to 150. For medium stones and finishing stones, you can use 180 to 220. If you've already used the paper for the rough stone, it's okay to use the same paper for the medium flattening and the polishing stone. The posture that we're using here to sharpen is setting on your shins. If this isn't comfortable for you, you can experiment with putting pillows under you or setting on another block of wood to carry the weight of your body and get the strain off your knees. We're going to be working using mostly at this point upper body movements, and we want to eliminate all the swaying and movement that comes from our body when we're standing up. This gives us more concentration and control in our sharpening, and it makes it easier to concentrate and get the most accurate and efficient results. Now that we come into our shop, we put our rough stone in the water. It needs to soak. At this point, when the stones are starting to soak, I take a little water and put it on top of the medium stone and on top of my finishing stone, so that by the time I get ready to use them in the sequence, they have enough water and they're ready to be used. The rough stones are ready to be used when they stop bubbling. I would take the stone on the sandpaper and make straight pushes with it with my hand. It helps to rotate the stone from end to end at times to help keep the stone wearing down flat and keep the surface true. We do this until we think we've achieved the flatness and the trueness, and we check it by looking at the sheen of the water that runs down the surface of the stone with light reflecting on it. If this surface is flat and true, we will get an even sheen of water across the surface. If the stone is not flat, it will puddle in the middle or to a low point, and this will affect our straight edge on our sharpening, and we'll have to go back to the sandpaper to keep this stone flat. It helps to use the whole surface of the stone when you're sharpening to help keep from having to flatten and wasting your stone on the sandpaper trying to keep it flat. So once we have our stone flat and we've checked the sheen, we need to add just a little water to get started. The first part of the geometry, the chisel that we need to check before we start to sharpen, is the relationship of the cutting edge of the chisel itself to the axis of the chisel. This is best checked by looking at it with the chisel dangling between your fingers. If this surface isn't square to the direction of the chisel, we should correct it. This is important in that when we're using the chisel, if it's not square, the chisel will enter the wood and tend to make the mortise veer to one side or the other. Also, as we're inside the chisel, with the chisel working on the mortise, the chisel will tend to rotate to the short side of our chisel edge. So in keeping this edge square, it makes the chisel work much more control. To check that, to correct that, we will lightly pull the chisel on its edge along the stone until we've achieved the square that we desire. This is checked by looking at it in the light and seeing what's called the line of light along the edge. It's the light reflected from this edge, so that if there is an edge here, then it won't be sharp. You want to do as little as possible with this to bring the high side down to the low side. At this point, we've corrected the trueness and the squareness of the edge to the chisel. We will go to the second part of the geometry, which is flattening the back and seeing that that is a true surface. We do that by going to the rough stone and making a few light passes with the finger on the bevel end of the chisel and pushing the chisel across the stone to see that the stone cut on the steel and create a series of scratches that give it an even sheen. This should be repeated until we've developed the point of the surface being that even sheen. Once we've done that and corrected any deflections in that surface, then we're ready to go to the bevel side and actually sharpen the chisel. This chisel geometry has the flat surface on the bevel, which needs to remain in contact throughout the stroke. This is helped to be controlled by the grip of the right hand and the left hand in coordination pushing across the stone. The pressure is put with the finger and the push is with the right hand on the handle. It's important that you let your wrist rotate as you go through the stroke to not deflect this angle by picking up the rotation in the circumference of the shoulder movement in the stroke across the stone. The pressure on the cut is on the push stroke with the chisel in square motion to the direction of the stone and releasing up on the pressure and letting the chisel float at the same angle to the stone on the return stroke. The cutting is all done on the push stroke. It's important that the strokes be consistent and predictable, and speed is only the last component that needs to be added to effective sharpening. You need to have control and predictability first. We continue on our rough stone, listening to the sound. You will notice that the sound of the rough stone cutting the steel is a much deeper, coarser sound. We continue that until we have thought we've reached a point where we have an even set of scratches on the beveled side, which shows that we have that is a flat surface to the level of this stone. At that point, we should feel a wire edge on the back of the flat side of the chisel with the hollow ground. When we have achieved those two objectives, we can return our rough stone to the water and we'll move to the medium stone. The medium stone I'm using here is a natural stone called Tashima stone. It's a very fine stone to use in the sequence. It will remove the scratches from the rough stone and create a very fine burr on the flat side, taking off the scratches from the rough stone. It needs to be flattened in a similar method as the rough stone. The rough stone and the medium stone are the two stones that actually shape the chisel and give it its form. So it's very important to control and correct the trueness of the stone if you're looking for a flat edge, a straight edge on your cutting surface. Again, this stone is a natural stone and just needs a slight sheen of water on the surface. It's important to flush off any residue that comes from the sandpaper onto the stone so that you're not going to impregnate into your stone or to cause deflections or coarse scratches in your surface that you're trying to polish out. You'll notice that this stone has a much quieter sound than the rough stone. So our first process on this again is like the rough stone. We will go to the back side, make a few passes with the pressure on the beveled side of the end of the chisel with the flat side on the stone itself to remove the burr from the rough stone. It's important that this burr be removed on the stone and not broken off with your finger, and that will destroy the straightness and the fineness of your edge. After a few passes have been made, the wire edge should be gone. You should start to see that this edge is the surface in the back on the land has been brought to a very fine set of scratches that are characteristic of the middle stone, and all the rough scratches and the deep scratches from the rough stone have been removed. It's important at each step along to take out with this stone the scratches from the rougher stone, because when you get to the finer stones and the polishing stone, that's a very hard thing to do because the cutting ability is more of a polishing. So once we've flattened the back, we check for even scratches, remove the burr, we go back to the beveled side and repeat the technique that we had with the rough stone. At this point, I've moved the chisel slightly off a square to the direction of the stone and pushing so that I'm passing over the scratches from the rough stone in an oblique angle and not following the trail of the rough scratches from the rough stone. This is a very, very fine, quiet sound and shouldn't take too many passes to get rid of the scratches on the rough stone. It's better to make a few passes with the medium stone and check it than overworking your tool and doing too much work that isn't necessary. Again, we will check to see that we have even scratches across the beveled side, and our lamination line and the forging line should start to show up more because the surface is actually getting smoother. We should, from this stone, get a very fine wire edge or a burr like we did on the rough stone. So once we have achieved our two objectives of getting rid of the rough scratches and our wire edge, we will go to our polishing and finishing stone. The stone I'm using here is a natural stone called a uchigamori. It's a very fine polishing stone. These polishing stones need to be kept flat and true as the other stones, but they have no effect on the actual shape of the blade itself. It's just the polishing aspect. These stones are usually used in conjunction with the white nogura, which helps to bring up the paste, which aids in the cutting and polishing and the balancing of the steels and the stones to have a more effective color. You can tell that by making a few passes on your stone to see if the steel is being removed by the stone. If the steel, after a few passes, isn't starting to show up, take your nogura, a little water, rub it on the surface of the stone till you see the paste come up, and then stop. It's important that this paste and the water that's on the stone not be removed or washed off before you start to use it, because the paste on the stone is what's doing the polishing. So we make enough appropriate passes to clean up the back side, remove the burr, and remove the fine scratches from the medium stone, and we should see a very satiny, highly reflective surface in the steel. At this point, we're ready to go back to the bevel and polish the bevel side of the chisel and clean up any other deflections that we find in our surface. Again, the pressure is felt with the finger and the hand on the bevel, maintaining that bevel in complete contact along the length of the stroke. The pressure on each progressively finer stone is less pressure than on the previous rough stone before. Again, if we're not seeing any steel coming off on the stone, we need to add a little nogura until we do. The stone isn't working unless you see steel being left on the stone itself. Again, you will notice that this polishing stone has a very quiet, muffled sound, and it helps to amplify that if you mount your stone on a wooden block that has helps to stabilize the stone and hear what the sound is of the stone in itself. As you're working and the stone builds up or dries off, add a few little drops of water from your fingers onto the stone to keep the surface moist and well lubricated. This will be continued in this process until you have achieved the polish that's to your liking. At this point, we should see the lamination line and any forging lines that are left in the steel. We should see an even surface and a flat surface. We shouldn't see any scratches other than what the polishing stone has left in the surface itself. At this point, we'll go back and clean up back side, the flat side of the chisel. There shouldn't be a wire edge on the back side. It's just a matter of cleaning it up and completing our process. So once this has been cleaned up and polished, we usually dry the chisel off, taking off all the slurry and the water, in that the high carbon steel rusts very fast with water on it, so it's important to keep these tools dry when they're not being sharpened. Once it's been dried and cleaned off and inspected, I use a camellia oil and an oiler to wipe a little oil on this surface to keep it dry and to keep the water from having any rusting effects on the steel itself. Now, in analyzing and looking at how our chisels came out, we should see that the bevel side of the chisel is perfectly a flat surface, and that if we rotate the chisel in the light source, we should see the whole surface flash in one surface. If it comes and picks up facets or a rolling effect on the chisel itself, this was probably caused by not letting your wrist rotate in direction with the chisel and you picking up the radius of your arm and rounding this surface. If the edge dives off, looking at it, picking up the light, that's probably from your movement of your return stroke being more up on the point of the chisel, rounding this off. It's very hard to do that on a push stroke because you would dig into the stone. The other problem that's generally encountered is that in sharpening your chisel, this edge moves off of the plumb that you established when we first started. This is usually caused by an improper grip or alignment of the grip on the chisel, which transfers the torque of the arm muscles into the chisel and creates more pressure on one side than the other. This should be adjusted so that this pressure is relieved by rotating your hand to the side that needs to have more pressure on it. These are all very simple adjustments and are easy to accomplish with a little bit of experimentation and paying attention to what you do. You want to be sure not to rock your chisel because this flat surface really helps in being able to have effective mortising when we get to doing our projects. Now that we've gotten our tool sharp and we've oiled it and inspected it and it's up to our standards, we're ready to go back to work. Now that our tools are sharp, we're ready to go to work. One of the important factors of this kind of work is the height of the workbench that we'll be working at. It is adjusted to your own personal height to probably the bottom of your knuckles. This helps you to be able to work at this bench without having to use clamps, because you can use more of your body weight for holding the lumber and sawing and mortising, setting on the pieces. It's also helpful to have carpets or mats on the floor where you're working and standing so the tools fall off on the floor. They don't necessarily hit something hard to give them a chip. The basis of Japanese joinery is the mortise and tenon is a wood-to-wood connection. It is most effective when it's cut very accurately. To cut accurately, we need our sharp tools that we just sharpened. Japanese traditionally use softwoods. They are very consistent grain fibers and not the hard and soft layering that is common in most hardwoods. They also have very good weathering capabilities and are bug resistant. The mortise itself is cut with the chisel. The tenon is cut with a saw. The mortise is usually cut first because that's the hardest part. The basis of this joinery is called a compression fit, which means that it has a tighter fit and a compression of the grain fibers along the lateral dimensions of the joint and not so tight along the side dimensions. This snug fit will hold things in place. If it's too tight across the grain, it can cause cracks or splitting later on. It's better to have joints a little looser than a little tighter so they don't split, but what we're trying to get is the perfect fit. In doing this and getting the accurate layout which is necessary for this fit, we use Japanese layout tools. One of the oldest devices used in this is called the sumitsubo. It's a piece of bamboo that's been split and sharpened on one end to a very fine edge. The other end has been whittled down and pounded and used as a marking device for writing numbers or indexing your pieces. The straight edge that's sharpened to a fine point that gives you a line has many advantages over a pencil or a pen or a marking knife. It gives you very consistent, even lines that are very legible and easy to read, and it won't wash off after it dries. These lines also are left right on the surface of the wood, so they're easy to clean off. There's no denting or scratching in the wood that would cause you to have to take too much wood off to get the wood clean again. The sumitsubo is used in conjunction with the sumitsubo, which is an ink pot which has raw silk or cotton with sumi ink and water in it. It also has a line that goes through it with a sticking pin that controls the line on the piece so that you can snap straight lines. This line is rolled up through the ink into the wheel at the end of the sumitsubo. Water must be added to keep this mixture so that it can flow from the pen onto the wood. Not too much water, though, or it gets very sloppy. These lines are drawn around the pieces, and the layout is done with a Japanese square. These modern tools have a knife edge on them which facilitate the ink not bleeding back underneath and making your layout too messy. These modern ones are made of stainless steel. The old ones were made of copper. These squares could be adjusted by tapping the thick end at the 90-degree point on the outside to close them and tapping on the inside to open them up. I've had this square for quite a while, and it has yet to need any adjustments. The square is used normally in laying out with the edge over the side of the wood, and the sumitsubo has been lightly tapped into the top of the ink to pick up ink. It is drawn in a straight line with very light pressure across the wood. This gives you a very clean line. One pass should be enough, not numerous passes. Again, you want a very clean, legible line. It's very important that these lines are consistent and very accurate. If our layout lines aren't accurate, then we don't have the confidence to go ahead with our joinery. And if we're trying to make mental adjustments on changing things later to make it work out, that's a mistake from the beginning. We need to have complete confidence in our layout. If the layout lines aren't right, clean it off, plane it off, and start all over again. The layout I've done here for this mortise and tenon is laid out here. We lay out the mortise and the tenon off of the same layout, the same dimensions. Our compression fit will make up the difference in the amount of the lines that we leave in the right dimensions that we want. We'll lay out the mortise and tenon at the same time using the same dimensions. In our initial cuts, we will stay inside our layout lines, and that lets us have a much speedier process. And once we've cleaned the rough part out, we can go back and very delicately pare out right to our lines. In layout, we're trying to create the three dimensions of the joinery so that when we reconstruct and put our joints together, we've reestablished our layout by having half the line left on the tenon and half the line left on the mortise, and we're reconstructing the layout from the original dimensions. It helps that when we're laying out and cutting our mortise that we're aware of the size of our chisels. We would like to have our chisel size be just slightly less than the width of our mortise, so that it gives us a little room for cleaning up. If the chisel that you're using is less than the width of the mortise, it's best to stagger your cuts as you're going through in your technique, as opposed to doing all one side and trying to come back and pare off the excess waste on the other side. Again, these chisels are used with a metal hammer that is a very well balanced hammer. There are lots of styles in terms of the shape of the hammer head itself, but all have the same construction and have one thing in common. The end of the hammer that is hitting on the chisel has a convex surface. This enables the chisel to be hit in the middle of the handle and not along the edge, which will cut the mushroom to the wood off and hitting the bezel. The position for using the chisel in mortising is in a flat position with the beveled side down. It's more effective this way, and it's only used on the flat side for paring. With the position of the table at this height, we're going to use our body to hold the wood in place by positioning ourselves over it and using our weight or our body. This position varies depending on the size of the timbers. On small pieces, we can work this way. If we were working on much larger timber frame pieces, we probably could work right on the floor sitting on them. Our process for mortise and tending here of cutting the mortise is we would start from our layout lines right inside the layout to make a shallow stop cut. One light cut just inside the layout line, and we'll V across the grain to remove the material so that there is a short stop cut there. We do this on both ends of the mortise, just inside the layout lines, removing that piece. The second procedure is doing the lateral dimensions of the mortise by lightly tapping and scoring these lines. By drawing the circumference of the mortise on the wood, that helps to prevent the wood from chipping out over that, and we can control all the wood that's removed from the inside of the layout. Once we have these indentations and we're just inside our layout lines, then we're ready to start cutting the joint. The technique that is used for cutting this mortise is very similar to digging a hole with a shovel. We're using the flat side with the bevel side down. This gives us more force from the hit holding the end grain down, and we don't get wood pulled out from the end because of the tearing out of going past the end grain. We'll be cutting across the grain mostly because of the way the Japanese chisel is constructed. These edges, when they were sharpened and flattened on the back, are sharp enough that the shear of going across the grain will clean the outside edges up, and we usually only have to pare the outside edges to get our final fit. At this point, I would be making cuts from the top of the mortise only. I will start in the middle. I've made my stop cuts at the outside. I will start in the middle with a shallow V, and I will continue this mortising halfway through in a V shape back to the shoulders, leaving this margin at the outside edges. Once I have completed this V to the midpoint of the mortise, I will turn the mortise over, doing the same process of stop cuts and outlining the inside of the mortise. And I will start at the outsides and with stop cuts coming back to the inside and relieving the inside into V. Once I have pushed the mortise through and I have an opening from the inside, past this I only have the humps on the outside. At that point, it's easier for me to tell where my shoulders are going to be lining up with each other by just removing the waist back to this line, instead of trying to guess at this point where this square is and pushing on through to the bottom where I can't see. It's important to remember to only work where you can see so you can control what happens and you don't lose the accuracy of your layout because of cutting in directions that you can't control because you can't see them. Now, once we have our stop cuts made, we have ourselves positioned over the wood, we will start in the center of the mortise. Make one cut and the second cut comes from the other side and is underneath the cut to move that chip. Once we have that chip removed, it's a process of chipping this side and coming back from the other dimension and cutting underneath the chip that we just removed. The size of these chips varies with the sharpness of your chisel and the type of wood you're using. It's more effective to take off light, thinner chips than try to take a big chip at one time where you have to pound too much. It's more efficient to work faster and take off less material. This process is continued till we have reached the shoulders, the outside shoulders of the mortise on the top, and we have gone approximately halfway through the depth of the mortise. Let me continue this mortise. By undercutting each chop, that removes these pieces. Sometimes we have to come back and move these out because we've cut the pieces, but the compression of the material inside has held it in place. We haven't removed the material yet. We've only cut the cross grain. It's important that you keep the mortise clean of chips while you're working, so you can have more access to keeping the mortise free. So at this point, we can see that we have our beginning mortise from the top side. Halfway through, we have our shoulders and our V. We will turn the piece over and repeat the same procedure. Again, starting with stop cuts just inside the shoulders of our layout line. Scoring lightly inside the lateral dimension along the grain line of the mortise. If this mortise was laid out with a marking gauge, then the marking gauge itself would be adequate enough to stop the wood from chipping out on the outside. We go back to the middle point, taking out the initial V. We continue our process of undercutting the material that's in between our layout lines. In most layouts for mortise and tenon, the layout is determined from the center line, not from measuring from the outside edge in. This gives us a much more advantage when we get to doing more complicated joinery and more acute angles or obtuse angles in our mortising as opposed to just the square mortise. At this point, you can see that I do have my hole through the mortise all the way through, and I can see light through here. Now the process is coming back and cutting these humps off and bringing it back into the line of the square of the mortise of the depth. If this is a lot of material, you can go ahead and chisel this out. If it's less material, you can use your paring chisel just for a light cleanup. On this amount of wood, I'll come back and chisel it out. This should go relatively quick for you when you're working. Again, I'm starting at the outside edge of my humps and moving back to the square line, moving at a diagonal towards the middle as opposed to square. Most of this can be done from one side. One of the advantages of doing this with the chisel in this position is that as you drive the chisel, it tends to come out. If you're driving your chisel this way, it tends to move into the wood and will cause you more problems. It's easier to control in this position. So once I've removed most of the waste from the top, I will turn the piece over, making sure that all the chips are removed from under the wood, and do the same process at the top, moving closer back and square to the shoulders of my layout. It's important when you're working to be able to be over the top of your work so you can tell more of where your cutting is going on. When you're removed and far back, you don't have the right control, and you don't have the balance to be able to make the corrections. At this point, we have the shoulders fairly cleaned off, and we probably just need a couple little cuts here to cut the shavings themselves so that we can push them on through and have our mortise more or less roughed out, ready to go. So from here on, we can use our chisel in the paring position of flat, or we can go to a paring chisel that has the size that we can fit in here. Now, I will clean out the inside of the mortise with the paring chisel. Paring chisels give us more leverage and are more control because of the design of the handle. Again, at this point, we're pulling our cuts right back to the line, working only in the top. We've removed all of the waste except for a very fine paring, which is why we're working and controlling our cuts at this point. Working from the outside of the hump back to the shoulder. At this point, we take part of the end of the mortise off, and we'll come back and clean up the outside line so we get nice, crisp, clean corners. At this point, we want to have all our material moved with just leaving the line on the mortise. Once we've got our mortise to the size we want, we have this little bit of waste left that we can make the adjustments to fitting our tenon. One of the reasons that we do the mortise first is so that we can see that we come out to the dimension that we had on our layout line. If the mortise creeps a little bigger than we had planned on our layout, it's easier to make the tenon fit the mortise than it is to make the mortise fit the tenon. Once we have the inside cleaned up, we check it by eye, removing all the fragments of material that are inside. Looking to see that we have a clean, flat, true surface from one side to the other. We should eyeball this first to start developing our eye to tell flat and true lines, and then we can come back with a square and check the diagonals of the piece itself to see that they are square. If the mortise is bigger than this one and you need to see more, it's easy to put sumi ink on the edge of your square or pencil lead and rub that on the inside, which will indicate the high spots to show what we need to take off to get it right back to our exact dimensions. At this point, the mortise should be completed and we're ready to cut our tenon. Now that we've finished our mortise and we checked the alignment of the tenon and the layout of the mortise and that they meet up like we had originally planned, we're ready to make the tenon. The tenon is made with a Japanese saw. Japanese saws are a very unique tool for woodworkers. They are very well balanced by their construction, and they have a unique advantage in that they work on the pull stroke. This is different than in the push stroke of Western saws. Being that they cut on the pull stroke, that lets the saw have a much harder piece of steel, which gives you much sharper teeth. This sharpness is also a factor in letting the saw blade itself be much thinner and having a smaller curve, which means that you're actually removing less wood. Teeth on Japanese saws in general are very fine compared to Western saws. These blades are also scraped thinner in the middle to keep them from binding as you go into the kerf. There are two types of saws usually available in Japan. The ryoba, which means that the saw has teeth on both sides of the blade, and a dozuki, which is a saw that has teeth on one side. This is a crosscut dozuki. It has crosscut teeth that are very fine. This dozuki has a very thin blade with a backing on it to make the blade rigid so it's easier to use. This saw is excellent for making any crosscuts up to a 45-degree cut. Over a 45-degree cut, a dozuki with ripped teeth is very efficient. This saw is an actual true dovetail saw. Within the range of ryobas, the same style has many sizes. This is a 130 millimeter ryoba. This is a 180 millimeter ryoba. And then the two standard sizes that are used are the 240 millimeter ryoba and a 270 millimeter saw. The size of the saw that you should use should be in a comparison to the size of the lumber that you're working. The general rule of thumb is that the length of the saw blade should be about twice as long as the depth of the size of the piece that you're using. This only makes sense in that the saw blade should pass through the piece of wood to clean the kerf out and get rid of the cut that's been made, to clean that out. These saws have very high carbon steel and need to be kept well oiled and free of water. Each maker has a different steel that he uses and a different temperament process that gives it a very special quality. This saw is a very special saw that has great flexibility and will be very hard for a beginner to use. The general type professional saw has a little more stiffer blade, which lets it track a little better. Other saws on this style are an anabiki saw, which has teeth on both sides. Again, it has the crosscut teeth and the rip teeth. These teeth are a little coarser than the flat-edged traditional ryoba, and they cut a little faster, but the cut that you get is a little rougher and will probably be needed to be cleaned up. Other saws available are saws with teeth on one side called a yokobiki, which is a saw with crosscut teeth. This is very good for large timbers or cutting big shoulders on your tenons. The other style is a single-sided saw called tatebiki, which has rip teeth on it. This is good for ripping boards or for sawing the dimensions of the lateral side of your tenons. You will notice that it has much smaller teeth at this end than it does at the far end. This is to facilitate an easier start when you're getting into the wood with the smaller teeth. A new addition to the Japanese saw market is saws with replaceable blade. These saws have a screw in the handle which the blade can be replaced without having to send it to have it resharpened. The best of these replaceable blade saws are the ones that have an electro-hardened edge on the teeth, which makes the softer steel of these machine-made saws last a little longer. Again, these saws can be replaced with that being resharpened, where your traditional saw should be taken back to the place that you purchased it, and they will send it back to where they got it and have the maker resharpen the saw himself. The use of these saws is very different from Western saws. Being that you're cutting on the pull stroke, we will want to start the cut away from us and advance the cut towards us. This is done by starting with the more rigid end of the saw that we can control, doing the major part of the sawing in the middle, and doing the end up of the sawing at the foot of the saw. This foot has a shoe on it, which is the angle that the saw works most efficiently at. As we notice, this is a much flatter angle than what we're used to with traditional Western saw. Ending up sawing on this foot will help save the saw from the most common mistake used in using these saws, and that is sawing through the wood and having the saw blade go into the table or what you're working on. This will distort the teeth and knock them out of set and probably render the saw fairly useless. To begin our cut, we should be in a balanced position over our work so we can see where to start, and we should always remember that we want to saw in the waist part of our layout. It's good to use your thumb or finger as a fence to start the saw in its proper alignment with the layout line, and with gentle motion start the saw again with the end of the saw near the handle that's most stiffest. We will advance the cut towards us across the piece of wood until we have made a slight curve in the wood. And at that point, we will start to rotate our piece of wood, keeping the saw in line with the initial curve. The wood is rotated as the saw follows that curve, creating a miter box to help guide the saw blade along the desired line. As we rotate the wood, we want to be sawing and advancing the cut only on the side that we can see so we can control our cut. These saws are not made to saw from one side straight through in a traditional Western manner. Once we have sawed diagonally through the piece, we rotate the saw to the next part of the layout line and continue to advance the cut where we can see it. As the saw approaches the continuity of the curve, and we hear the sound change, we will rotate to the end of the saw that has the shoe on it to protect our saw. At that point, when the saw drops through our cut, again, it was protected, it was on the shoe itself. Now that we have discussed the cross-cut technique, we'll look at the layout of the tenon. In this tenon, you can see we have the four shoulders on this tenon, and the waist part has been indicated by slashes or by dots. This is very important so we keep a clear image of the piece that we want. We will saw all our rip cuts in the waist part, revealing the tenon in the middle of our piece of wood. Now let's go to the end of the bench and do our rip cuts. This position of squatting in front of our work, using the table or our workbench as the stop and our hand as the stabilizing factor, is the most efficient posture for making rip cuts. This is a little different than we did with the cross cuts, in that normally we try to advance the cut towards us. But in this situation with a short tenon, we should be able to guide our cutting with the near the blade where the smaller teeth are. We need to make first a moving start cut line. Once this cut has been made, we'll rotate the wood over to the other side and make the same cut on this side, connecting this piece, this cut to the bottom cut. Once we have made that cut, we will start advancing our cut back to the shoulder of the tenon, working in this curve that we've started, again using it as a miter box. It's important that we start the rip cuts first and do them. It gives us much more control over sawing off our shoulders. If we oversaw our rip cuts, all we do is put a slight curve in the shoulder. If we've oversawed the shoulders off, then we come up with weakening our tenon because we've sawed into the tenon itself. Once we have made our cut from the shoulder cut to the opposite corner on the diagonal, we rotate our wood back and advance the cut again on the side where we can see where the saw is going. Again, we never want to advance the cut on the bottom side where we can't see. This technique is holding the saw in a very balanced manner and advancing the cut in the curve back to the shoulder. We should stop slightly before the shoulder so we can control that final cut. Again, the other side of the tenon is sawed in the same manner. Lightly moving it to start the top curve. Rotating the piece. Once we've shoulder with the diagonal, once we've reached our diagonal, we'll rotate the wood and go to the other side and advance the cut where we can control, make them using the same technique. Now that I've finished the other two cuts, I will come back and check my rip cut to see how close to the shoulder I am. After a little practice with your saw, you will get to feel where this angle is and you can get much closer to it. But for beginners, you probably should stop a little short and come back and check. This is easy to see by running the saw in the kerf and looking at it from the top and seeing that the line of the cut is right to the shoulder. We should check all sides of the mortise to see that the sides of the tenon to see that we're right back to this line. Again, this kerf is going to help us judge when to stop our cross cuts to get the shoulders off and revealing the tenon that's inside this waist that we've just sawed. So now that I've checked the sides of the tenon, I will come back and I will use my dozuki for sawing off the shoulders. The technique again for the cross cut is we want to start from the far side and extend the cut to us using the short end of the saw. The saw teeth on the dozuki are the traditional teeth for sawing the cedars and cypresses that are used in Japan. I will start my cut and extend the kerf along the waist of the layout line, not sawing that piece off. It's important only to make the kerf and rotate the saw in that kerf along the layout line. What we're trying to achieve here is not 4 separate cuts, but one circular cut that has all these faces within one plane. Again, we'll rotate the saw and advance the cut to us. Once we have connected our lines and we followed our layout all the way around, we will again make our cuts starting to penetrate the waist and starting to reveal the tenon. We can tell the sound of the shoulder coming up to the kerf because of the rip cut that we had in the beginning. At that point, all the waist falls off, and we can check to see how true our shoulders are. These shoulders should be parallel to the layout lines that we have. We'll check to see that the surfaces are all nice and flat and even, and any deflection or bulges in them, we will clean off with our slick chisel. And using this chisel, we can go at a sideways motion across the tenon using our thumb as a guide. Sometimes it's easier to get a smoother finish on our cuts if we're shearing our lumber in the cut instead of just going straight across the grain lines. At this point, we're just taking off any obvious deflections in the tenon. We laid right out to the side of our layout lines, so we should be very close to the fit with the mortise. We won't take off too much, so we have some room to come back and adjust our tenon size to fit the mortise. Once we've taken off any obvious bulges, we'll stop and we will check our tenon and see that its alignment seems parallel with our layout lines. We can also do this by laying a square up on the side and sighting it to see that they're not whopping one side or the other. Now, we return to our mortise and check the size of our tenon to see how we're doing. At this point, we looks like we're very close, and we need slightly just to pare it off and to clean it up. It's generally a good idea to remove a little bit of wood at first and check it before we get taking off too much and lose our compression fit. Once we have the size that we want, we'll come back and put a slight chamfer on the entry end of the tenon to ease that entry. Paring into the side we've already chamfered, we will slightly ease the corners of our tenon with a very fine chamfer. This takes the pressure off the corners so that it doesn't develop stress cracks at that point. Once we have this cleaned up, it looks very nice, we'll come back and check it for our fit. The compression fit in the cedars and cypresses should have this squeaky fit. At this point, we will look and check from both sides to see if our mortise has a deflection and our tenon is going in a proper mode. If this is a square mortise and tenon, it must be put together square. At this point, it looks fairly good. We'll take it out.